Welcome to our calculus video presentation on the application of derivatives in real-life scenarios. Hi, my name is Kosherin, the leader of the group.
Hi, my name is Emily.
Hi, my name is Nia Zahra.
Hi, my name is Archana.
Today, me and my group will be exploring how this mathematical concept helps us to understand changes and solve everyday problems. Let's dive in.
My name is Emily Carvalho Lim, and I will be giving a short introduction to our topic, applications of derivatives in real life. First and foremost, what are derivatives? So a derivative is the instantaneous rate of change of a function with respect to a variable, also known as the differential coefficient of y with respect to x. This is, I think, the most well-known definition of a derivative. And next, they can help us quantify the sensitivity of a change of a function's output to its input, also known as how the manipulation of the input affects the output. And lastly, I think this is quite a popular explanation as well. Graphically, it is known to be the gradient of the tangent to the function's graph at that point. So next, what do we use derivatives for? Well, first, derivatives allow us to study how functions change over time. As mentioned before, we can figure out the ratio of how much our output changes to how much our input changes. Basically, what small change in y is observed when we have a small change in x. Studying the relationship will help us identify what direction the function is moving in at any point, and predict the behavior of the system or function under different conditions as things change. Mathematically speaking, derivatives can help us to find the rate of change of a quantity, the approximation value, the equation of a tangent and normal to a curve, maxima, minima, and point of inflection. It also helps us to determine increasing and decreasing functions. In the real world, however, there are many things we can apply this concept to. Various fields benefit from the application of derivatives such as physics, engineering, economics, and more. And that is all for my introduction. Thank you so much.
Hello, madam. My name is Nia Zahra, and I will be explaining the first problem statement. So my problem statement is related to total profit maximization. And in total profit maximization, the total revenue and total costs are expressed as a function of quantity. And in order to find our profit, we will have to take the total revenue minus the total cost. So we can denote this as Px equals to Rx minus Cx. And in order to find our maximum profit, we will have to find the derivative of Px, which would be dP over dx. So we can see this in my question, which is determine the number of shoes, X, needed to be made and sold to maximize profit, Px, in ringgit, given the revenue and cost functions. What is the maximum profit? So in this question, we would have to find the number of shoes, which is X, and also the maximum profit. So in this question, we are given the revenue and cost functions, which is Rx equals to 60x minus 0.5x squared, and Cx equals to 3x plus 8. So, like I said before, we can find profit by doing Px equals to Rx minus Cx, which would be 60x minus 0.5x squared minus 3x plus 8. So that would give us 57x minus 0.5x squared minus 8. And we need to resusun it as 0.5x squared plus 57x minus 8. And like I said just now, in order to find maximum profit, we would have to find the derivative of that. So if we do dp over dx, we would get negative x plus 57. Now, in order to find our maximum profit, we would have to let dp over dx equals to 0, which would give us x equals to 57. So this is the number of shoes that needs to be sold. That needs to be sold. Now, we have the number of shoes that needs to be sold, which is x. Now, in order to find our maximum profit, we would have to substitute this value of x into our original equation, which is Px. So we would put that as P57 equals to negative 0.5, 57 squared plus 57 times 57 minus 8. So if you calculate that, it would give you RM 1016.50 cents. And that is how you use derivatives in profit maximization. Thank you.
Now, I will be explaining about problem statement number 2, which is how we can use derivative to estimate a population. The question states that the population of a city is tripling every 5 years. If its current population is 10,000, what will be its approximate population 2 years from now on? First, we can let P of t equals to population t years from now on. Since the question has given us that the current population, which is t at 0 years, equals to 10,000, so we can write it as p bracket by 0 equals to 10,000. The question also tells us that the population is tripling every 5 years. So when t equals to 5, population equals to 10,000 times 3, which gives us the value 30,000. Next, we need to find the population growth rate. To calculate current population growth rate, we can use the derivative of current population size, which can be written as p prime of t. So current population growth rate equals to rate of change of population size, which means it can be written as change in population size divided by change in time. So we are going to use the population size in 5 years minus by current population size and then divided by 5, which gives us the value 4,000. As we've learned in our syllabus, we can use the first principle to find the derivative of the function. Apply this same concept to this question. It gives us that the current population growth rate equals to population size in 2 years minus current population and then divided by 2. But the question requires us to find the approximate population 2 years from now on, which means p bracket by 2 is actually what we wanted. So we need to move the 2 to the opposite side, becomes 2 multiplied by the growth rate, and then move the current population size to the opposite side, become plus current population size. So this gives us the value that the approximate population 2 years from now on equals to 2 multiplied by 4,000 plus 10,000. So the answer of the approximate population 2 years from now on is 18,000. That's all from me. Thank you.
Here I will explain the problem statement 3. The question states that assume that oil spilled from a ruptured tanker spreads in a circular pattern. So it's in a circle pattern. Calculate the rate of change of the area. The question asks us to find the rate of change of area when the radius is 60 meter. So the radius is 60 meter. If the radius is increasing at a rate constant of 2 meter per second. So this 2 meter per second is the rate of change of the radius. So what we can do here is that we can write down the information given where radius is 60 meter, dr over dt is 2, and we can write down the area of circle which is pi r square. And the question asks us to find the dA dt. So dA over dt is equals to dA over dr times with dr over dt. From the question, the dr over dt is given. So we need to find the dA over dr. So dA over dr we can derive from the area of circle. So if we differentiate pi r square, we will get 2 pi r. So substituting back into this, we will get 2 pi r times with 2, we will get 4 pi r. And the question also already stated the r value, which is 60 meter. So if we substitute here, we will get 240 pi. If we calculate this, we will get 754 meters square per second. So since the question states to find the area, the unit for area is meter square. So that's all for this question.
That's all from us. Thanks for tuning in to our video presentation. Bye!
Bye.